Okay, so for 2-2, this is where we got started. We just talked about this yesterday. Standard form of a linear equation. A standard form of a linear equation is ax plus by equals c. So standard form depends on the type of equation, right? So standard form of a circle doesn't look like this. This is standard form of a linear equation. Then we talked about how to graph when it's in this form using the intercept method. So we want to plug in 0 for y to get our x-intercept, plug in 0 for x to get our y-intercept, and we want to make sure we write those as ordered pairs. So x and y-intercepts are points, so they should be written as ordered pairs. And I'm going to keep them as fractions here. Okay, so we already had that from yesterday. Plot those points, connect them, and align. Okay? Okay, so let's keep going. Let's talk about slope. So again, something you should be familiar with, the slope of a line, our slope given any 2 points. y2 minus y1 over x2 minus x1. We use m as our variable to represent slope. The book will use this notation sometimes. So this triangle here is a delta. It's the Greek letter delta, and in math, delta means change. So it's delta y over delta x. Delta y over delta x. Change in y over change in x, which is the rise over your run. So that means with slope, remember you're going up or down before left or right. So normally you move left, right, then up, down, but slope is opposite, rise over run. Okay, and word problems, rate of change means slope. So if you're looking at a word problem and it wants you to find the rate of change, that means you're finding the slope. Okay, so if you have a positive slope, then your line increases from left to right. So you always look left to right. So as x goes from left to right, your y values increase if it's a positive slope. So that means it goes up. Okay, then it's negative if looking from left to right. So as x increases from left to right, your y values decrease. So just read your graphs left to right to know if your slope is positive or negative. If they're going up, it's positive. If they're going down, it's negative. Okay. All right. So we'll talk about special cases, horizontal and vertical lines here. All right, the special name of a line of x equals 3. So that's the equation of the line. So if I have x equals 3, here I am at 3 on the x. And what type of line would I draw through that point? Vertical. Okay, so this is a vertical line. So it's a vertical line. It cuts x at x equals 3. So it's x equals, that means it cuts x, so it has to be a vertical line. And then the slope of a vertical line is undefined. Okay, so if vertical lines are x equals, then what type of line do you think y equals -5 is? Horizontal. So here you'd be at -5 on the y. So to cut y, you have to draw a horizontal line. So if the slope of vertical lines is undefined, what's the slopes of horizontal lines? 0. Good. So this chart talks about this here. X equals h, so vertical lines always are x equals. H is the x-intercept. Horizontal lines are always y equals, and whatever that is, k is your y-intercept. And this is what we just talked about. The slope of any vertical line is undefined. The slope of any horizontal line is 0. So parallel and perpendicular lines. Okay, so this talks about that two lines in the same plane, so any type of plane here. It makes more sense to look at it on a coordinate plane. If they never intersect, then they're parallel lines. What makes them never intersect is that they have the same slope, equal slopes. So looking at line 1 here, if I look here on blue, my rise over run, so I go up 3, that's positive 3. And I go right, 1, 2, 3, 4, positive 4. Okay, if I look at the second line, the red one, if I start here, my rise is positive 3, and the run is positive 4. So the slopes are the same, so the lines are parallel. So this chart just kind of explains the definition here. So if the slopes are the same, then the lines are parallel. Then the converse is also true. If the lines are parallel, then the slopes are the same. In symbols, parallel is this double line here. So you maybe remember that from geometry. That's the symbol for parallel. And then any two vertical lines are parallel. Same thing with horizontal. Any two horizontal lines are parallel. Perpendicular lines then. Perpendicular lines intersect at right angles. And their slopes are negative reciprocals. We'll call that opposite reciprocal. So perpendicular lines have opposite reciprocal slopes. So if I compare their graphs on the coordinate plane, line 1, the blue, the slope is 1, 2, 3, 4, positive 4, 1, 2, 3, positive 3. Line 2, so I'm going down 3, that means negative 3. And 1, 2, 3, 4, right 4, positive 4. So opposite reciprocals. So if I say that my slope is 4/5, what would the perpendicular slope be? Negative 5/4. Right. So what about if the slope is negative 1/2? What's the perpendicular slope? 2. And if your slope is negative 5, what's the perpendicular slope? 1/5. Good. Okay. So saying that they're opposite reciprocal means that their product is negative 1. So if you multiply those together, negative 3/4 and positive 4/3, you get negative 1. Opposite reciprocal slopes give you a product of negative 1. So that's just kind of how they write it in technical terms. They don't say opposite reciprocal, they say that the product is negative 1. So if they're opposite reciprocals, then the lines are perpendicular. Then you have the converse. If it's perpendicular, then their slopes are opposite reciprocals. The symbol for perpendicular looks like a upside down capital T. That's the perpendicular symbol. And then in general, any vertical line is perpendicular to any horizontal line. So remember, horizontal and vertical lines are your special cases. So all horizontal are parallel to other horizontal. All vertical are parallel to other vertical. And then all horizontal are perpendicular to all vertical. Okay, so let's do an example. You're given 2 points from line 1 and 2 points from line 2. Use the slope formula to determine if they're parallel, perpendicular, or neither. So my slope formula, y2 minus y1 over x2 minus x1. Alright, I have 2 points on line 1. Remember, every point has an x and a y. This is my first point listed, so I'll call those x1, y1. This is my second point listed. So I want to find the slope of line 1, so I'm using this little L1 as a subscript. So y2 minus y1 over x2 minus x1. So I get -3 on top and -2 on bottom. Keep it as a fraction, but always reduce or simplify so the negative over negative is positive. Okay, same thing. Let's find the slope of line 2. So here's my first point. Here's my second point. So 5 minus 3 over 1 minus 0. Okay, 2 over 1 is 2. So are these slopes the same? Are they opposite reciprocals? So are the lines parallel, perpendicular, or neither? Neither. So they're not the same, and they're not opposite reciprocal. So they're neither. Okay. All right, so we're going to look at a few word problems here. So again, if you don't want to write all of it out, note the problem number. We're in section 2.2. Anytime you're given directions, you want to graph those. So I'm going to draw a coordinate plane here, and I'm just sketching. So I know the harbor is here at 0, 0. So the first trawler goes 12 miles north, so that would be what direction? Up. And 3 miles east, so that would be right. So up 12, right 3. So as an ordered pair, that's 3, 12. Okay? So this is trawler 1. And the second line goes 2 miles south, so that's which way? Down. And 8 miles east, that's right. And so what would that be as an ordered pair? 8, -2. Okay, and that's trawler 2. So first of all, it says, are the routes the trawlers perpendicular? So I want to know if those two lines are perpendicular. So slope of trawler 1, just do rise over run. So you go up 12 and right 3. That's 4. And then I want the slope of trawler 2. So I went down 2, so negative, and left 8. And that reduces to -1/4. So are the routes perpendicular? Yes, because these are opposite reciprocals. And then if so, how far apart are the boats? So I want to know now this distance. So use distance formula. I'm going to call this the first point. So x1 minus x2 squared plus y1 minus y2 squared. Calculate just what's underneath first. So we get 221, right? Okay. It says, to the nearest 1/10 mile. So that means it wants you to approximate. We get 14.9 miles. Make sure you label. So word problems really, a lot of them aren't that hard. So don't get scared off just because you have to do some reading. Take it one piece at a time. If you have directions, then you want to plot that on a coordinate plane. Okay. All right, we're going to do a couple more word problems here. So remember, this is the section on linear graphs. So these all word problems here, they'll be linear, okay, linear equations. So it doesn't tell us we have to write an equation here, but I'm going to go ahead and do it because it's not hard to do, number one. And number two, it can make solving, especially part B, easier. So let me just say, okay, B is value. I'll go ahead and use x, but you could use whatever you want for your variables. Number of years. So the value equals, how would I write that equation? 1.50x plus 85. So the value is going to increase from 85. So this is our starting value, and then we have 1.50x. Okay, you could write it 85 first and then plus 1.50x, that's fine. All right, so everybody see how we wrote that equation? Okay. Part A, what is the card's value after 7 years? So what are you going to plug 7 in for? What variable? X. Plus 85. Okay, so calculate that. What do we get? Okay, and what's the label here? So I found value. So I want dollars. 95 or 50. Okay, now part B, how many years will it take for this card's value to reach $100? So what do you plug 100 in for? B. So it didn't say you had to write an equation. So if you didn't write an equation, then for part B, the way to do that, it would just be guessing and checking numbers for X. That could take a long time, a lot longer than this. So subtract 85, we get 15. Divide by $1.50, and we should get 10. And what's the label here? Years. Good. questions about that? Okay. So take a minute to read this. This is not a difficult problem, but because it's kind of lengthy to read, it maybe seems confusing. So read it through. Okay, so first thing I note is this problem gives me an equation. That's always a gift. So if you have a word problem that gives you an equation, then the hard part's done for you. The rest of the work is just going to be you solving and then interpreting your answer. Right? So the hard part's done when you have the equation. Okay, so up until this equation, everything above it is just extra information. It's kind of explaining how they got this equation. All right, so don't look, you're not looking at 7% or these years, you're starting here. Okay, so start the problem here. All right, so part A, I want to find the percentage of physicians that were female in 1992. So first of all, it gives me 1992, which is a year. Are years X or Y? X, okay? So, but I have to know X equals 0 represents 1980. So what would I plug in for X if I want 1992? 12. Good, 12. So I'm going to plug that in my equation. What do we get? I'm sorry, what? Okay. And percent. Good. Part B, I'm given percent, so is percent X or Y? Y. And it does tell me that Y represents a percentage as a whole number. So I'm not changing that to a decimal. Most of the time I know when we work with percents we have to change to a decimal, but it tells me it's a whole number. So subtract 11 from both sides. So round to 1 decimal place for me here. Okay, 26.4. So that's the number of years after 1980. So when I want to write that as a year, and just want to make sure that we're telling you right here. Okay. Okay. So if you want to write that as a year, so first of all, your 26 years, so just look at the 26 part. If you're starting at 1980, what year would that be? 2006. So let's assume that this was 1980 January 1st, 1980. Okay, so 2006, if you add exactly 26 years, then you're at January 1st, 2006. 0.4, you're not quite at year 2007, right? You're still in the year 2006, so that's going to be our answer. Okay, does that make sense? Even if that had been 26.8, you're still not at the year 2007, so you would say 2006. Okay, so even if this had been more than 5, so like 26.8, you would still say 2006. Do we see why? Okay. Okay, so we are going to start 2-3, so stay with me.